Hello everyone, I am Love Tudor and I'm an Android developer and technical writer currently at Frontend Labs. Today we're going to be talking about code surgery, refactoring for a healthy app. There's this quote here by Martin Fowler that says, "Whenever I have to think to understand what the code is doing, I ask myself if I can refactor the code to make that understanding more immediately apparent." So in this presentation, basically, we'll delve into the world of code refactoring and we'll talk about its advantages, its benefits, and explore practical refactoring techniques you can implement on your code base to ensure that you have a cleaner, more understandable, and easier to maintain code base. So let's get started. So firstly, what is code refactoring? Basically, it's the process of restructuring your existing code without altering its external behavior. It primarily focuses on improving your code's internal design, its readability, and ensuring that it's easily maintainable. So think of refactoring your code base as a house. So to make your house more functional and like aesthetically pleasing, without changing its overall footprint. So you can have a room, for instance, you have a sitting room where you have lots of wires connecting to your TV, connecting your TV to the wall socket, right? And it's all crumpled and messed up, right? You can think of code restructuring as finding those wire clips or wire tips to help organize the wires so that it looks more neat and organized. So you're not removing any wire from your setup, your TV setup. You're just ensuring that it looks nicer, it's easy to look at, and it's easy to pick to select which is the TV socket or the TV wire or the speaker wire and stuff like that, basically. So yeah, so that's what we're talking about, and we're going to see how we can do that with our code base. Let's move on quickly. So why refactor your code? Why is it important to refactor your code? Well, firstly, a clean code is easy to read and understand by yourself and also your fellow developers, right? So you might write the code today and it might look complicated, and you in 2 months or 3 months, when you're going back to look at that code, you'll be like, oh my god, what was I thinking when I was writing this, right? So refactoring your code makes sure that your code base is easy to read and understand both by yourself, your future self, and also your colleagues or future developers. Also, it improves maintainability because a refactor code is easy to modify and it's very easy to add features to it in the future. And as we know, software is always changing, so things are always, some libraries or features are always getting deprecated, so you need to update that. So if your code is clean and easily maintainable, making those changes would be quite easy. But if your code is quite tight coupled, you'll find out that when you're trying to make a change, there's a ripple effect of errors and bugs all around because they're tightly coupled to each other. Also, reduce bugs and code smells. So when your code is well structured, right, it reduces the chances of having bugs creeping in during development. And finally, that we'll take today, improves team collaboration. So when your code is clear and concise and easy to read, it just fosters a better communication between your colleagues. Yeah, so we talked about code smells. So code smells are indicators of potential problems in your code base. There are various examples of code smells. You could have long methods. So probably you have a method that so let's say this method, one method for getting your user's name. That same method, you're using that same method to get your user's let's say your user's height, your user's your users height, basically all your users details, right? Just from one method, and you're calling that method get user details. So you're using it to get the user's name, get the user's date of birth, and all of that. Then the user can also set their height in that one method, right? So that's a really long method. Or you're having duplicate code where you would have to convert your user's height to in maybe from inches to centimeters, and you're doing that conversion in every place wherever you have to do it. Like you're literally writing that code that converts from centimeters to inches or vice versa. um you literally write it everywhere you use that. So those are duplicate code. You're writing the same code in everywhere, right? And then God classes. So now you have a user class that also has user payment details in it and performs payments, like maybe subscription, monthly subscription, right? So maybe you have a class called user, and then you write renew subscription or pay subscription or subscribe in that class. That's a God class, right? It's doing everything for the user, because we have this single responsibility principle that says that a class should focus on one thing. So if it's just the user's details, it should have just the basic user's details, right? And all of that. And then you have long parameter lists. So maybe when you want to create a user object, right, you would have their name, their phone number, their email, their height, their date of birth, and then you find out that you have let's say you have 15 parameters. That's a long list. And also magic numbers. So okay, let's give an example. Maybe you have features for adults of over 18, and then in your code base you're writing if user's age is greater than or equals to 18, right? And then you're just writing the 18 like that. So when another developer is going to look at your code, they're like, okay, 18, what does 18 mean, right? So we're going to talk about how you can work on all these code smells. And then nested conditional statements. So you're having lots of if else, else if, else if, else if, else if, right? Sometimes those nested if statements makes it difficult to understand what the logic is really doing. So these are just examples of code smells in your code, of some common code smells. So yes, challenges of refactoring. Of course, you would face some challenges when you're refactoring, and number one is time constraint. So you're short on time and you have to refactor. Sometimes having a very short time frame for your refactoring could be a bit challenging, because before you can refactor a code, you need to fully understand what the code is doing, right? So that might take a little more time, and sometimes you might need to write tests before and after to ensure that everything is working perfectly. So yeah, time constraints, especially when you have a deadline to meet, to maybe a pre-release feature, and then you want to refactor something else. So time constraints could be a challenge. And then fear of breaking things, because you're going to tamper with a code that's already working, right? And then testing overhead. Yes, you need to test to ensure, and probably write more tests to ensure that nothing was broken while you were refactoring things. And then lack of awareness. So not knowing the benefit of refactoring, or the essence of refactoring, like why are we really doing this thing, right? So that could just be a challenge too, when your colleague is like, no, it's not finding it useful. They may, or your stakeholders are not finding it useful, going back to code and working on code that's already working, right? Why are you touching it if it's working? Yeah, so challenges like that. And then legacy code. So when the code is not well documented, it's difficult to understand, especially if you are not the one that wrote it. Well, sometimes even when you write code, right, you might go back to it and you totally don't remember a bit of what your thinking process during that. So yes, legacy code is also a challenge. The time it will take you to understand what you were trying to achieve, or what this particular piece of code is trying to achieve. And now quickly we're going to look at refactoring techniques. Moving on quickly. So first of all, we have composing methods. So in this case, the refactoring is basically devoted to correcting methods, like we talked about earlier, the long methods. You could streamline methods and remove code duplication, like creating methods for, like we said, the inches, the centimeters to inches conversion. You're going to create a method for that, or you have a very long method, you're going to break that into sub methods, right? And then we also have moving features between objects. So this technique basically shows how you can remove functionality between classes. Like maybe you have, like we talked about the god class earlier, right? So you can extract the subscription class from the user class and ensure that there is separation of consent for each class. So each class just has one responsibility it's focusing on. And next we have organizing data. So this particular refactoring technique has to do with data handling, like replacing primitives with rich class functionality that has other helper methods and all of it, right? Fourthly, we also have dealing with generalization. Here we deal mostly with abstraction, with your interfaces. Maybe you have to move a method up, or you need to remove a method from a super class, or from an interface, or add a method to an interface, or replacing creating new classes um, from an interface. So basically things like that. And of course, simplifying conditional expressions, like we talked about earlier. Having those nested if else statements can actually sometimes most times makes the logic very difficult to understand. So one way you could do that is by using when statement in Kotlin, and which you can just say when this condition, then do something, and then it will just go through the when conditions and then execute the first condition that's met, and then that's it, right? This is just an overview of few refactoring techniques that you might encounter while refactoring your code base. We're moving on quickly. So refactoring best practices, what you should look out for while refactoring your code base. Firstly, like I said earlier, understand the code. And so you need to review the code to understand fully its process, its methods, objects, variables, and other elements in the code. What are they doing and why are they doing what they are doing? And then next, you need to refactor in small incremental steps to minimize the risk of repeating yourself or the risk of undoing what you've done because you've lost track of what you were trying to achieve, right? So you factor in small incremental steps. This is an example. So maybe you have a full-blown app that let's say an hotel management application, right? Where you can, just like hotels.ng, where you can search for various hotels around you, I think. Yes, so one way you can go into refactoring in small incremental steps is maybe this application was written in XML and now there is Jetpack Compose, which is the modern toolkit for building Android UI, and it's faster, it's more reactive, and all of that. So then you want to convert the whole of this hotel booking application from XML to Jetpack Compose. So what you could do is you can start with the search feature. So now the search feature is actually quite large. You would have the search empty screen, you would have the search results screen, you would have the search field itself and all of that. So what you would do, how you would how you would refactor this in small incremental steps is, instead of saying, oh, I want to redesign the whole search flow, right? You can start by changing, okay, this search bar is XML, so you replace the edit text there, just the search field, the field where you type in, where you type in your text and search. You can replace that search field with a Jetpack Compose component, integrate that Jetpack Compose component with the existing XML code and ensure everything is working fine. And then from changing the search field, you can now convert the let's say the search results, because when you search you get the results, right? So you can now start creating for each of those items in the list. So you can rewrite the item view, the result item view from XML to Jetpack Compose, attach it back and ensure everything is working well. And then that's how you can just easily migrate from bits to bits, right? Documenting every step of the way. And thirdly, write unit tests before refactoring to ensure functionality is preserved. So this is actually important, because when you write unit tests, you are going to now be testing against those tests that were passed. So this is a very easy way for you to find out, oh, something is not working. Your previous unit tests will help you easily pinpoint errors that must have come in while you were refactoring your code. And fourthly, document your changes to keep your team informed and maintain code clarity. So, okay, I updated the search field using Jetpack Compose. Let them know it's the search field you updated. And then when you're, moving over to the item views, you can then say, okay, I'm currently working on the item view. So everybody is clear on what you're doing, especially if you are working as part of a team, and also even if you're working alone, so you can keep track of what you have done and what is left to be done. And then automate wherever possible. There are tons of refactoring tools that can help you, which I will list later on very soon in this session. So make use of them as much as possible. Some of them helps with formatting, like KT-Link, to ensure that your code is well structured and easy to the eyes. And then there are other inbuilt IDE refactoring tools. Like for instance, in Android Studio, you can find duplicate classes. You can also find, like for instance, in Android Studio, you can find unused classes or unused methods, and it will suggest for you to delete those. So yeah, automate whatever is possible. And then fix software defects separately. So this is an error that people might be prone to. This is a practice that people might be prone to default in, right? So maybe you're refactoring and then you find out, oh, okay, I don't think the search is working properly. I think there's a mistake somewhere, or maybe the filtering is not working as expected. It's supposed to filter out the first 10 results, but then it's filtering out 11, right? Your refactoring is not the time where you start fixing bugs. If you found out any bug, you can report it and focus on the task, so that you can efficiently and accurately measure the time you've spent. And finally, refactor first before adding updates or new features to existing code to reduce technical debt. So if you know your code base has some technical debt or needs some refactoring, right, it's always advisable that you refactor before adding more code on top of it, because the more the code, the more you have to refactor. Yeah. So yeah, and moving on quickly, let's have some practice. Firstly, like we talked about the long methods, one way is to break them down into smaller focused methods that have clear responsibilities. So each method should ideally handle a single step or subtask within the overall functionality. And then when each of these subtasks are you can now call this subtask sequentially in its in a parent task, right? And then we also had the God classes, like I said, having subscription details and card details in your user details, right? In your user class, right? So you could break this down into smaller classes focused on basic functionality. So your user details should just have details about your user, their name, their basic details, right? And then you can have your subscriptions or your cards. You could have a card class, a class for your cards or subscriptions, right? And then you can also utilize delegation to distribute these responsibilities across multiple classes. So maybe you would want a particular object to behave a certain way. You can delegate it to a particular class that implements it that way, right? And then the long parameter list, like we had having over 15 parameters, a way you can do is to create data classes or helper objects to group these related parameters. So you can, instead of passing username, first name, last name, age, and all of that, right, you can group that into the user class that you created earlier, and then they just need to pass in that object, right? And then you can also utilize default parameter values for optional parameters. So maybe so that whenever you're calling that method, you don't always have to pass in 15 values. So maybe out of the 15 values, 10 of them are default parameters. So you don't need to call those 10, especially if the values correspond to what's supposed to be imputed in. And then you can also consider builder pattern for complex object creation with many parameters, so that you can just easily add parameters as they go, right? So you can do user dot username dot users user age, right? So you don't need to call the whole 15. You can just call and initialize what concerns you or what you would want to update in your code base. And then magic numbers, like I talked about the 18, having 18 written there. So you could just call it age limit. So instead of writing hard coding 1 and 8, that's 18 to your logic, you can just write. So if the age is greater than or equals to age limit, good. So you define constant values for the number and give it a name that's easy to understand. Or you could also use configuration files or resource bundles to store these values. And then again, the if else hell, I already talked about using when statements. So you can use when statements for handling multiple if else, and you can also refactor complex logic into separate functions or use the strategy pattern. And finally, we're going to look at some refactoring tools. Most IDEs come with some refactoring features. Like I said, Android Studio, you can find classes and methods that have not been used. You can also find deprecated code with Android Studio. So these are just refactoring tools that would help you. And then there's also JRefactor, there's SourceMage, there's Code Rush for Visual Studio, and there's Refactoring Guru, which is a web platform. And so that's all of this for this presentation. Thank you so much for having me here. If you have any questions or you would want to discuss further about code refactoring, you can send me a message on Twitter, on formerly Twitter, now X, at Lamar Sparrows, or you can send me, you can reach out to me on LinkedIn, Love Otudo. Thank you so much for having me. I do hope you enjoy the rest of your IWD event. Bye.